Hey guys, welcome to your Unit 10, Lesson 6 notes. It is your last notes of the year. Wow, crazy, huh? Anyway, let's get started. By the end of the day, you'll be able to solve inequalities involving absolute value. Remember that absolute value is that you absolutely have value and you matter. While that is true, absolute value is a number's distance from zero. So basically it means just be positive. So it's just like stay positive because it's always going to be positive unless it's zero. For example, two numbers with absolute value of 3 we can represent with this beautiful number line. And we're looking for numbers that are 3 away from 0. And that's -3 and 3. So if you have the absolute value is equal to 3, then x equals -3 and x equals 3. Cool. But what if you have, I should have made these all less than or equal to. I'm going to do that. No, I can do open circles. Here we go. All right. So what if their absolute value is less than 3? That means they are closer to 0 than 3 is. So it's going to be all of these guys. If their absolute value is less than 3, they're going to be in the middle here. This is going to be an AND statement. So we say that x is between -3 and 3. But what if the absolute value is greater than 3? That means their distance is not less than 3. It's more than 3 away. So it's these guys and it's these guys. Okay? That means it's farther away from 0. Further, farther, I don't know. This is going to be an OR statement. So either x is less than -3 or x is greater than +3. So here with absolute values, you're noticing that we make like a banana and split. So when you're working with absolute values, when you're working with inequalities and absolute values, you need to split it into two cases. One needs to be the positive value, and the other needs to be the negative value. So let's do some examples. Here, if we look at the absolute value of x is less than 4. That means either, so I like to just kind of imagine this. Whatever this is, if the absolute value is less than 4, then that number has to be between 4 and -4. Okay? So that means we take the positive side, we have x is less than +4. But the negative side is -4 is less than x. Is that great? But we don't, it's not x, it's x minus 7. So that was bad. That was bad of me. I'm sorry. We're going to take whatever is in our absolute value. It's not x, it's x minus 7. So x minus 7 is less than 4, or x minus 7 is greater than -4. And now we solve. We're going to add 7 to both sides. That gives us that x is less than 11. And also on this side, we're also going to add 7 to both sides, which gives us 3 is less than x. So there you have it. We're going to combine these two together. But remember, when we write inequalities, the symbols need to go the same way. Oh, look, this gives us an AND statement. So if we were to graph all the numbers, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2. So we have open circles at these guys, and we are highlighting what comes between them because their distance, the distance of this number is closer to 0 Oh, so it's got to be an and statement. In fact, whenever you have an absolute value that's less than something, that will always be an and statement. On the other hand, if we have an absolute value that's greater than something, that will always be an or statement. Remember that if you have absolute value greater than, that's going to be whatever this value is, it's going to be further away. It's going to be further away. Excuse me. So when we split this guy up, it's either going to be that whatever is in your absolute value, that's going to be greater than or equal to 40, because that'll make it farther away from 0. Or the other way to be farther away from 0 is to make it less than or equal to negative 40. Whoa, crazy. So here we go. So either 5x is greater than 40 or 5x is less than negative 40. So we split and we solve. Make like a banana and split. We'll divide by 5. We'll eventually divide by 5 over there, so I'm going to do that. That gives us x is greater than or equal to 8, or x is less than or equal to negative 8. Oh, that's cute. That'll go really nice on our number line. 0, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Nope, that's a negative. Okay, so now let's put them together. X is greater than 8, greater than or equal to 8. Gives us a split this way. X is less than or equal to negative 8. Gives us a split that way. And that's our solution. So if you have greater than, that will always be or. Less than, an absolute value is less than, is always going to be and. Now when are we going to use this in real life? Well, we often use inequalities with absolute values to talk about something called tolerance. Tolerance is like your margin of error with like giving like an interval that you're allowed to be in or that you cannot be in. For example, Mariah at her most recent basketball game, her score was within 6 points of her single game scoring average of 32. So it was within 6 of 32. How are we going to figure this out? Well, I'm going to graph it first, and then I'll show you how to get there algebraically. So if her average is at 32, that means she either went plus 6 or minus 6. So she was within 6 of that 32. So to go back 6, gives us 26 or 38. Okay. So if she's within there, then she is somewhere between 26 and 38. Is that a lot? I think that's a lot. Good job, Mariah. Probably more than I can do, so respect. Anyway. So, how do you calculate tolerance? Well, here's how to do it algebraically. First, you're going to take the possibility. You're going to assume you spelled it right. You're going to subtract the ideal from that, and that absolute value is going to be less than your tolerance. So here, our tolerance was 6. We are within 6 points. Oh, just kidding. Yeah, that's what I wanted. Okay, nice. Okay, and then the ideal, that's the number that's going to go in the middle. So ideally, she gets 32. Well, I mean, ideally in this case, she gets more. But like what we're searching for, our goal here is 32. And then the range of possibilities, I guess I should have made this gray because that's how I illustrated it here. This is gray down below, and then the range of possibilities of scores is represented in yellow. There you go. That's better. Ah. Okay, so we would set this up to say, okay, Mariah's score is, I don't know, X for unknown. So we would say X minus her ideal, or her average, is 32. The absolute value of that is less than or equal to 6. And then we would split and solve. So if the absolute value is less than or equal to 6, then either X minus 32 itself is less than 6, is less than or equal to 6, or X minus 32 is greater than or equal to negative 6, because these numbers are going to be closer to 0 than 6 is. To undo that minus 32, we're going to add 32 to both sides. So we get either X is less than or equal to 38, or X is greater than or equal to 26. And we can combine those by putting them all in the same direction. So I'm going to flip this guy around. Give me 26 is less than or equal to X. And then we overlap them. 26 is less than or equal to X is less than or equal to 38. So Mariah's scores were somewhere between 26 and 38. Cool? Cool. Now we've got our friend Will working at the skate shop, and he has to balance his drawer and be within, where's my gray highlighter? Nice. He needs to be within $4 of the expected balance. So according to like the calculations on the cash register or something, we expect that he has $2, wow, he didn't sell very much, $207.30. So how much is Will allowed to have in his drawer? He's allowed to have some errors in case, there was like petty change, or he dropped a quarter or whatever. Okay, so what are the acceptable balances for his drawer? Well, we know that the possibility, what he's allowed to have, we're going to subtract our ideal from there. And then the absolute value of that needs to be less than or equal to our tolerance. And our tolerance today is 4. So that'll give us the absolute value of, we don't know, X minus 207.3 is less than or equal to 4. I should have made this blue in the spirit of color coding. There you go. Awesome. And now we solve it. So if we know that the absolute value is less than 4, it's going to be closer to 4. So either this value is legitimately just smaller than 4, or it's greater than negative 4. To solve this, we're going to add 207.3 to both sides of our inequality. And while it's here, I might as well do this on this side as well. So this will give us that either X is less than 211.3, or equal to, or X is greater than or equal to 203.3. So what does this mean? Well, if Will went overboard and he has less than if he has more than $211, that means he didn't give someone back the change that they need. Oh no. But on the other hand, if Will has less than $203.30, that means that someone didn't give him enough money, or he gave back too much change. Oh no. Either way, this is the range of acceptable dollars that Will is allowed to have in his register. So to graph that, we go from 203.3 to 211.3. We've got solid circles. He's allowed to be anywhere between there, as long as he promises to have a fantastic time on his homework.